Hello, my gems. Today we're going to do our midterm review number 3 over triangle congruence theorems. So hopefully you remember all those proving triangles are congruent in those 5 different theorems that we learned. After you complete these notes, you can go online and you can take the midterm review number 3 triangle congruence Quizlet. That is 5 questions. They look very similar to this one. So let's get ourselves started. Before we even get going, I'm going to write down the 5 congruence theorems, if you remember them. So they are side, angle, side. Angle, side, angle, 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 side, 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 and HL. Remember, we can't swear forward or backwards, so A, angle, side, side, or side, side, angle, that is not a congruence theorem. All right, number 1, triangle ACB is congruent to triangle ECD, shown below. Which statement is not true? So in this picture here, I've got some segments that are already marked as congruent. I know these are vertical angles right here because they're across from each other, but it's telling me that these 2 triangles are congruent. So I don't even really need the picture. I can actually just figure out everything that's congruent based on the order that's lettered here, right? Because if A is first, that means angle A is congruent to angle E. C comes second, that means angle C is congruent to angle C. And B comes last, so B is congruent to angle D. So just by looking at the lettering here, I can determine which statements are true and false. So the first one says angle A is congruent to angle E. So A comes first, E comes first. That is a true statement. AC is congruent to EC. So AC are the first 2, then EC. Those match up. That means this is also congruent. AC, EC. So if I want, I can mark that on my picture. These are the angles from the first one. Angle B is congruent to angle E. Well, just by looking at this picture here, I can see angle B has to be congruent to angle D. And if I look up here at the lettering, B matches with D. So this one is not true. So that's going to be my answer, but we'll check the last one just in case. AB is congruent to ED. That is a true statement as well. So the statement that is not true is that angle B is congruent to angle E. That is incorrect. Number 2. For 2 triangles with identical orientations, that means they look the same, they're facing the same way, what rigid motion is necessary for side, angle, side congruence to be shown? So I've got a side, angle, side. I would have the same side, angle, side over here. Now, the only way to get from one triangle to another is by doing some kind of transformation. To translate means to slide. Rotate means to turn. Reflect means to flip, and dilation means to enlarge or make smaller. So to get bigger or smaller. So if I'm looking at this picture here, if they keep the same orientation, well, they're not turning, they're not flipping, they're not getting bigger or smaller, they are sliding from one to the other. So that is a translation. Number 3 is a pretty hefty question. But we're going to read it through and select the right answer. So Zane cut a drinking straw into 3 pieces shown below. So he's got one straw that's 2 inches, one straw that's 3 inches, one straw that's 4 inches. To investigate a triangle postulate, he moves the straw pieces to make triangles that have been translated, rotated, and reflected from an original position, right? So he's making a triangle essentially. 2, 3, 4, and he's taking that triangle, he's flipping that triangle over the other way. So he's doing something like this, right? Flipping it, he's translating it, he's moving it. The end of one piece is always touching the other end of another piece, so it always makes a triangle. Which postulate could Zane be investigating using only these straw pieces and no other tools? So is he trying to determine that the sum of the interior angles of a triangle is 180? Well, we're not talking about anything to do with angle measures. These are all side lengths, so that's not right. Letter B, if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Well, it does look like that's what he's doing, right? He's taking a triangle, he's flipping it, he's sliding it, he's moving it, but these triangles stay exactly the same. So that one seems like it could be the right answer, but we're going to go through and check just to make sure. The sum of the squares of the length of the two shorter sides of a triangle is equal to the square of the length of the longest side of a triangle. Well, that's essentially the equation a squared plus b squared equals c squared, the Pythagorean theorem, but I'm not actually trying to determine different side lengths. I'm keeping all of mine exactly the same. So since nothing's changing there, that doesn't really work either. If two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the triangles are congruent. Well, again, I'm only talking about sides here, right? I'm essentially doing the side, side, side postulate, and I'm trying to just take it and flip it and see if it's the same no matter what kind of translation or transformation I do. So that one doesn't make sense either. So my answer is B. If three sides of a triangle are congruent to three sides of another triangle, right, then the triangles are congruent. Okay, number 4. You are given that AD is parallel to EC and segment AD is also congruent to segment EC. We want to prove that segment AB is congruent to segment CB. So it says, shown below are the statements and reasons for the proof. They are not in the correct order. Which of these is the most logical order for the statements and the reasons? Now, remember, the first thing you always start with is your given information. So I'm going to come over here, I'm going to find which one's my given information. It looks like this number 3 is my given, so this should really be my first step. And then remember, you always start with your given and you always end with your proof. So your last statement should be AB is congruent to CB. So here's this statement. This should be your final statement, right? So there's 1, 2, 3, 4, there's 5 steps total. So this one should be your first. This one has to be your last. Okay, so given that these are parallel and these are congruent, that's my first step. My second step is to try to look at anything that I see that looks the same, or anything I see, maybe like some angle measures that I can mark. The first thing I see is that this makes an X right here, which means these are vertical angles. Vertical angles. So I'm going to find the statement that says angle ABD is congruent to angle EBC, which I see, boom, right here. So this is my second step. And there's my 1, 2 congruent symbols. Remember, we need 3 congruent symbols to prove the triangles are congruent. So I need one more piece of information. And looking here between what's left, right, that one doesn't make sense. So it's gonna have to be this one right here is my next step, number 3, because you have to have 3 congruent symbols. So angle DAB right here is congruent to angle ECB right over here, because these are parallel lines cut by a transversal. So remember when we did this, parallel lines cut by a transversal, 2, 3, 4, 5, 6. Essentially angle 1, 4, 5, and 8 were all exactly the same. And then angle 2, 3, 6, and 7 were all also congruent. So that's the same thing I have in this picture. Here's my congruent lines. Here's my transversal. It's essentially just flipped this way. These 2 angles have to be congruent because they're alternate interior angles. So alternate interior angles are congruent. That's my third step, which means my final step is to prove that the 2 triangles are congruent. And I can by looking at this, because I have 2 angles and a side that is not in between them. So it's angle, angle, side. That's my fourth step. And then because these triangles are congruent, that means all the pieces of the triangle are congruent. So my last step is that AB is congruent to CB, because I already proved that these are congruent triangles. So corresponding parts of congruent triangles are congruent. So it looks like my order should be, the first one is 3. So I already know it's not A and D. Next comes Roman numeral 2. Next comes Roman numeral 5. Next comes Roman numeral 1. And then last comes Roman numeral 4. So letter B looks like it's the correct order. Number 5. Given triangles GHI and triangle JKL, I give you some of the side lengths, and it says what else needs to be determined to prove that the two triangles are congruent using hypotenuse leg. So remember, for hypotenuse leg, you must have a 90-degree angle. Your hypotenuse across from the 90 must be marked, and then one other leg of the triangle also has to be marked. So I'm going to draw myself a little sketch here. I'm not quite sure where the 90-degree angle is, so I'm just going to draw a regular triangle, which is okay. So I'm going to draw two triangles, and I'm going to make sure I label them in the same order. So G, H, I. I'm going to go in the same order when I name the next triangle, J, K, L, because I want them to be congruent triangles anyway. So I'm going to put them in the right spot. So GI is 5. HI is 4. JK is 4. And JL is 5. And then it says, what else needs to be determined to prove that the two triangles are congruent using HL? So I know one of these has to be my hypotenuse, one of those has to be a leg, right? Because they're both sides of the triangle, which means the last thing I need to know is that there is a right angle somewhere in the triangle. So the first one talks about side length GH has to be the same as KL. That doesn't make sense. I need something with a 90-degree angle. Same with angle H and angle K. I don't necessarily know that. What I need is something that has a 90-degree angle with it. Now the question is, where is your 90-degree angle? Now remember, hypotenuse means the longest side of the triangle. Longest side. And if you remember, the longest side of a triangle is always across from the largest angle. Now, if you think about a triangle, 90 degrees in a right triangle would have to be the biggest because the other two angles would have to add up to be less than 90. So my 90-degree angle should be across from the longest side. So if I'm looking at my numbers here, my bigger side is the 5. So across from 5 is angle H, and across from this 5 is angle K. So that means angle H is a 90-degree angle and angle K is a 90-degree angle. So I'm gonna come down here, I see angle H is equal to angle K, and they're 90 degrees. So there's my answer for this one. Okay, last one, number 6. Given the information regarding triangles ABC and DEF, which statement is true? So I'm gonna start by drawing a picture, and I always draw a picture because it makes my life easier. Two congruent triangles, name them in any order you want, but just keep the order the same. So I'm gonna go A, B, C, and D, E, F. Okay, so angle A is congruent to angle D, so I'm gonna mark that in the picture. Here's an angle. Angle B is congruent to angle E, so I'm gonna put 2 arc marks because it's my second pair of congruent angles. And then BC is congruent to EF, so that's a side length. So right now, I have proven these two triangles are congruent by the angle-side theorem. So let's look at the choices given to me. Let's pick the one that makes the most sense, the truest statement. The given information matches the side angle side criterion. The triangles are congruent. Well, I only have one side in each triangle, so that doesn't make sense. B, the given information matches the angle side angle criterion. The triangles are congruent. Well, angle side angle would mean that the side has to be touching both of the angles. It would have to be the included side. So it would have to be right over here touching A and B. Well, this is the non-included side. So because it's non-included, I can't use that theorem. Angles C and angle F are also congruent. So technically speaking, yes, they are, because I already proved these are congruent triangles. This must be shown before using the angle side angle criterion. So if I proved that these two triangles or these two angles are congruent, which they are, they have to be because I've already proven this to be true, I then could use the angle side angle criterion because there's two angles with the side right in between it. But I would have to have angle C and F before I did that. That looks like that works, but let's check the last one to make sure. It cannot be shown that the triangles are necessarily congruent. Well, that's false. I already showed it the first time around, so that's not true. So my answer has to be C. So I also hope that you're noticing as you're going through these problems, you can definitely do some like process of elimination, get rid of things you know aren't right, and that'll help you out. All right, so now we are done with our triangle congruence video notes. So now you can go onto Canvas, find the one that says Midterm Review 3, Triangle Congruence, and you will have an online Canvas quiz that's 5 questions that look very similar to the ones that you see here. So go ahead and give that a try, and good luck.